This is a tricky proof. So the first thing we want to do is we want to look at the diagram, see how we can mark up the given. So we're going to go ahead and do that to start. And then we'll do a little bit of troubleshooting to figure out how we're going to prove that the two triangles are congruent. So AB is parallel to DE. We can mark that in. That's not too bad so far. Obviously, you might be thinking alternate interior angles right now at that point, but we'll get there in a second. DC is congruent to FB. AC is perpendicular to DB, so I have a right angle right in there at 1, and EF is perpendicular to DB, so angle 2, I have a right angle. So I see the right angles. I'm considering HL, but I don't see any hypotenuses marked. You don't have to mark this in if you don't want to. But this side is the hypotenuse in this triangle, and side AB is the hypotenuse in the other right triangle, and they didn't give them to us as congruent, so I can't really use HL. I have to use one of my other shortcut methods. So that makes us go back to the drawing board, but some things they did give us that we can use, for instance, the parallel lines. So when I have parallel lines, I have alternate interior angles congruent to each other. So that gets me a pair of congruent angles at angle B and at angle D. Okay, so I have an angle, now I have two angles from my right angles. Now I'm looking for a side because I need a side in a shortcut method to make it valid. Since they did give us that DC, this piece is congruent to FB, that's a good little clue that we should be using those sides. However, those aren't full sides in the actual triangles we're working with. DC is just a part of the side. If I continued DC the full length through C and F, I would get a full side in the bottom triangle. And same thing going the other way. If I continued this segment BF through the length of CF, I would get a full side in the upper triangle. So since I have two short things and I need to make them a little longer, I'm going to have to use the addition postulate to get me a full side in both the triangles. So I'm actually going to mark this reflexive property because that's what I have to add on to my two smaller chunks. So I'm going to have to use addition to take the two smaller pieces and make them longer using that reflexive. So in this proof, my plan right now is to use the addition postulate because I had two short things that I need to make longer, so I'll add that reflexive in. And then once I have the addition postulate, I believe I do have a shortcut method. So let me see my next plan. So that's part one of the plan, is to use the addition postulate, get a full side. Part two of my plan now is to get a shortcut method. So what I like to do, because there's so many different congruent pieces in this diagram, is I like to highlight my triangle. And just one of them might be enough to help me see what my shortcut method might be here. So if I highlight this triangle, this top one, I can see that I have an angle. Then I have this side. And then I have my right angle. So this is actually going to be an ASA proof. It's really, really hard to see. You just have to take your time when you make that decision as to what you should be doing in your proof. So now that I kind of have my plan in place, this is my proof as follows. You could see it on the answer key as well if you're a little stuck. But I start with my givens. My alternate interior angles is what I hit next in my proof. I kind of went in the order that I marked things in. So that got me my pair of angles. Next, I started working with the reflexive property to get the addition postulate, where I show what pieces from one triangle I'm adding to be equal to the other pieces in the other triangle that I'm adding. That gets me my sides. And then I had my right angles from my perpendicular definition to get my second pair of angles congruent, which fulfilled my ASA. So feel free to look at any part of this video again, ask any questions that you might have in class. Thanks for watching.